Netflix is starting to use artificial intelligence to actually create the advertisements so they blend perfectly into the movie that you're watching. Hard to explain how opposed I am to this. Like on a scale from 1 to 10 to 10, for sure. OpenAI is taking AI software development to the next level. They introduced Codex, a cloud-based software engineering agent that can work on many tasks in parallel, powered by the Codex 1 model.
Codex set up the basics of the project, so by the time I got to my desk, I had that started for me.
Software development is changing. Known as Alpha Evolve, this is based on the company's Gemini large language model, and evolution plus learning equals intelligence explosion. A woman filed for divorce after ChatGPT reads her husband's affair in a coffee cup. Yeah, I guess it figured out that her husband was fantasizing about a woman whose name starts with an E. Scientists are now using AI to encrypt secret messages that are invisible to cybersecurity systems. James Douma, who's like probably one of my most favorite people that I want to interview on this channel, breaks down why the dancing Optimus robot from Tesla is just such a breakthrough.
Because, humans are an inverted planet. Walking is a miracle.
We're going to dive into this idea of continuous thought machines. It's an AI model that uniquely uses synchronization of neuronal activity as its core reasoning mechanism. Sounds pretty brain-like. Google Research has a new way to simplify text, but minimally. So it's not like explain it to me like I'm 5. It's like explain it to me in the exact advanced level that it is, but make it digestible and easy to understand. Big difference. Some interesting AI model rankings coming out of Poe. I mean, look, more people are making video on Runway than they are with Kling or Veo. That's kind of unintuitive to me. A research team from Meta has been studying how children develop natural language representations. Turns out AI models go through something similar. Rafi Brenna has an opinion about why flying cars won't take off without artificial intelligence. Duke University has been teaching theory of mind to robots, and it turns out it's enhancing their collaboration. And Greg Sattel breaks down why intention will be central to the AI economy. But first, if you want to support the channel, head on over patreon.com/DylanCurious. 91 members have already joined. I would love to keep growing that community. It's as little as $3 a month. Totally supports the channel. But even if you don't want to go to Patreon, that join button right here under this YouTube video pretty much does the same thing. Either way is a great way to support. Now let's get back into it. I'm going to start out with the strong opinion that I hate the idea of advertising done with artificial intelligence. I am scared of superintelligent mass persuasion. I mean, you thought misinformation was a problem. Wait until it's precision misinformation with intent. And I don't really see how this isn't going to quickly evolve into that. So Netflix will be using AI to make ad breaks that look less like ad breaks. This will lead to ads that fit seamlessly into shows where the characters are involved because Netflix will probably own the IP to the characters. Then it will just evolve into movies that have no ad break, but they literally have intention and persuasion built into the narrative. Is that the world any of us want? I don't think so. Maybe if everybody's like, I get things for free, but I also really need to drink a Coke right now, it's not free. So step 1 is AI generated ads. These ads right now will be appearing during pauses or as overlays mid-show. They are going to be matching the aesthetics of popular series like Stranger Things and Bridgerton, and the goal is to make the ads feel less intrusive and more integrated into the viewing experience. Now, I'm not going to pretend like you can really fight this. This makes a ton of sense for Netflix to move this direction. The same way they transformed streaming, they might transform AI-generated content in the future. This move aligns with the rapid growth of Netflix's ad-supported tier where people get to watch, I don't know if it's free, but it's definitely cheaper, $6 a month less or something like that. But that tier, that ad tier, it now boasts 94 million monthly users, more than doubling from last year. Now, right now, we're not at a place where all this stuff is so advanced that I'm that concerned, but with the rate of progress, I think maybe a year or two, I would seriously consider not watching something if it was ad supported versus if I can't pay for it to watch the movie, if they're not making the money from me directly paying them, then our intent is totally misaligned and I don't even think I want it. If someone's going to inundate me with ads like that, I should be getting rewarded or I want to stay away from that content. I've heard it said that the internet's original sin was being ad supported. All right, moving on. This is Codex. I'm really intrigued with this. So OpenAI has dropped a research preview of Codex. This is a new cloud-based software engineering agent. And it's sort of got this agentic workflow to it. I mean, it's like you ask it to do something and there's multiple agents, like a team of people building software for you. And they're taking on multiple coding aspects and tasks at the same time. Some of the things that it can do out of the box right now, it can write new feature, basically write code. It can answer code-based questions. It can fix bugs. And it could submit pull requests to like talk to a repo like GitHub, like pull and push onto, different stages or even to production. And it can do this all inside of an isolated environment. And it's powered by a different model. So I don't know if it's actually a reasoning model, but the new model is called Codex. Okay, yes, Codex is built on a reasoning model. Codex 1 is a specialized version of OpenAI's O3 reasoning model. Got it. Optimized for software engineering tasks. But yeah, it's really interesting. So you have this team of people creating code for you, and all of the agents have this file, this .md file inside of the isolated environment. And it's tracking what everybody does, everybody meaning the agents, via these logs. Like I changed this, I reviewed that guy's, that other agent's code, and now I wanted to make this change because this fits my goals and that fit, his or hers or them, whatever we call agents. And it all happens through this interactive online UI, this user interface. And when you read through their kind of like official PR announcement here, you'll see that there are some kinds of bugs that it really does seem superhuman at. For example, they talk about something, I'm kind of over my head here, but like nested compound module problems. I guess there was this long-standing bug. It was caused by false dependency mappings for nested models. And it made parts of the code wrongly appear tightly coupled when they weren't. And Codex was able to kind of dig deep into this code base and not only detect the bug, but also proposed a precise fix and validated it. And that shows that it's not just about writing like little snippets anymore. It's about kind of like deeply technical issues. A woman is filed for divorce after ChatGPT reads her husband's affair in a coffee cup. 12-year marriage down the tube. This Greek woman. All because ChatGPT told her to. Not directly, of course, but close enough. So full story is the chatbot reportedly saw signs of infidelity, specifically that her husband was fantasizing about a woman whose name started with an E, and that woman was trying to destroy their family. I don't know, but then she broke up with him, so she kind of destroyed the family, right? So I guess one day she made Greek coffee, and they thought it would be fun to take a picture of the cups and have ChatGPT read them, like read the tea leaves, or I guess something kind of like a tarot card reading or something. And it did it, probably mostly just as a joke. He didn't take it very seriously. I laughed it off as nonsense, but she didn't, he said. She told me to leave, informed our kids about the divorce, and the next thing I knew, I was getting a call from her lawyer. What? Why? Scientists have used AI to encrypt secret messages that are invisible to cybersecurity systems. This is kind of an interesting cybersecurity update. Scientists are hiding secrets in messages, and they say that using AI chatbots could lead to a world of ironclad encryption. I mean, I'm so concerned about these like black box systems not explaining why they make decisions that I already feel like everything's encrypted. I'm trying to like figure out what they are saying inside, because these agents can so quickly just turn into their own language communication systems. But researchers have now kind of taken that, they've harnessed it, they've developed a new novel method to embed encrypted messages with AI generated text, making them virtually undetectable to current cybersecurity systems. This technique, known as Embedder LLM, cleverly hides secret messages in human-like AI chatbot responses, allowing them to pass as ordinary conversations. Like, what the heck? This system requires a shared password or private key to decode the hidden content, functioning like a digital invisible link. And this kind of innovation holds promise for secure communication in environments where traditional encryption is restricted or monitored, such as under oppressive regimes. And the researchers acknowledged that there's a risk of misuse. They emphasized using this kind of technology ethically. I hope that helps. So to make this happen, they had to extract the 3D joint data, the skeleton of the human, and which was going to transfer over to become the skeleton of the robot. So when you copy the human action through joint data into this robot and it falls over, you can be like, hey, like you don't get a reward because you fell over. And if it stays upright, you get a reward. And the closer it gets to the expected action, the like better it gets. So it starts making all these little minor adjustments to actually be able to do it right when it's in the humanoid robot. And this is a new word to me, but that's called the shim layer, SHIM. Actually, I wonder what that stands for. Oh, interesting. So it's actually, shim is not an acronym. So every paper I read has like all these acronyms, but it actually comes from mechanical engineering, where a shim is a thin spacer used to make parts fit. A shim library intercepts unfamiliar, outdated API calls, tweaks the arguments, and then hands control back to the caller. So yeah, I guess basically just like keeps tweaking why the robot falls over until it doesn't.
What exactly, precisely, does the motor do? Well, in simulation, a simple simulation can get pretty close, but not close enough to make a robot work really well. You've got to get really, really close. And there's all this crazy nonlinearities in there. Now, you can take a model, like, the guys, if you're buying your motors off the shelf, you put one in a jig and you test and test and test and test to figure out exactly how it behaves. Because like I said, it's got all these nonlinearities in it. And then you make a neural network for that motor. And then you do it for another motor. And then you do it for every joint and every actuator and every ball bearing, right? Like every single one of these has a transfer function, which the neural network has to be taking into account because, humans are an inverted planet. Walking is a miracle. We're a pole, right? We're balanced. Like we take it for granted because we're humans, but walking is a very, very complicated challenge.
So if I'm understanding them right, if you have a neural network for every joint and actuator in these robots, that's kind of mind-blowing too, because robots, unlike a human, we have this like centralized brain and then everything's like going out to, the other parts of us. Like maybe I guess the brain in our head does like kind of simulate our shoulder and elbows, and that's why it works. But like maybe we have little brains, like an octopus has brains like all throughout its tentacles. Like maybe these humanoid robots will have full-on neural nets in their knees that just like excel at moving knees and ankles and hips and like, I don't know, like they might look like humans to us because they're in a humanoid form factor, but their brain being distributed in different ways, learning different things, might just be so superhuman, like it's hard to get your head around. All right, let's talk about the continuous thought machine model. This was Sakana AI. They published this. We're going to talk about thought machines. Okay, so they've taken on this pretty unique architecture for an AI model. It's called the continuous thought machine, and unlike a typical AI model, it treats time statically. Static. It doesn't move. Time is frozen. So CMT, these continuous thought machines, they incorporate timing into neuron activity, which allows it to think over time. So it's like in the human brain, it takes time for a wave to kind of like move across and like to trigger all the neurons. And there's something about the timing that's very much part of the learning. I guess when you're training a normal neural net and you just have these weights and you're fine tuning the activations, you end up with something that you just run it through it, but it's all like the amount of time it takes to get through it isn't necessarily part of what it learned. So by the CMT method, incorporating timing into the neuron activity, it allows it to think over multiple steps better. So the result is a more human-like reasoning and greater interpretability. By synchronizing neuronal activity and tapping into each neuron's past states, the model can solve complex tasks like mazes and image classification with more naturalness and efficiency. So these models, they're just naturalness and effectiveness. So these CMT models don't just give answers. It actually reflects. It reflects on the problems that it's trying to solve. And I guess, especially with these smaller models that they're testing on, it leads to enhanced performance. And like the reason why this might actually be kind of a big breakthrough or be something that we can learn a lot about the human brain from, like the feeling of consciousness, the way that we are, is when this kind of a system tried to solve a maze, it did it very human-like. This is not that much different than us like taking our finger, going to the starting point of the maze and like hitting a dead end and then trying to remember where we went and then trying another path. And it's also a little more human-like when it comes to image classification, right? In some sense, a lot of the traditional models, they do classify really accurately, but they don't jump kind of like the way a human eye would. And they'd look at like the distance between the nose and the eyes and like the color versus the background and then kind of put together that it's iguana or a tiger or whatever. It moves in a way that kind of mirrors human focus a bit more. So it makes me wonder if this is like pretty close to how the human brain works. Because those are emergent behaviors, and it seems like, what's in my brain might be an emergent behavior. All right, let's jump back over to some Google research. Making complex text understandable. minimally lossy text simplification with Gemini. So I am guilty of often going to ChatGPT, putting complex papers and things like in there and say, explain it to me in a simple, understandable way. But what I mean isn't explain it to me like a 5-year-old. That's usually what I get. And I think that gives me a disservice. It makes me understand it sometimes in a way that's just too like every person can get it, but it doesn't give you the details that you need. And I think my learning comprehension suffers, and unfortunately, I probably even pass it on through videos. So I was kind of excited when I saw that Google Research rolled out this interesting feature called Simplify, which helps turn complex text into something much easier to understand, but without losing the important or complex details. It just explains it to you in a way that's more readable. It kind of takes out jargon, but it doesn't lower the concept down. So, built using their Gemini language models, it focuses not on summarizing or explaining, but actually rewriting complex stuff in a clever way that still says everything the original did. And then the system fine-tunes itself by running tons of iterations where the AI checks and improves its instructions, like using another AI. And then they tested this new system with thousands of participants and showed that people understood simplified text better, felt more confident in it, and found that the reading was less mentally taxing. Oh my gosh, that's what I need so bad. Now, the only problem, which sadly should be the easiest to fix, is that they just didn't roll it out in a way that's very useful to me. It's a new feature in the Google app on iOS, but I don't really use that app. And it's not like I can just go to Gemini and do it. It doesn't really work for my workflow very well, but I hope this becomes something much more ubiquitous very soon. If you know a better way to use Simplify, let me know. I just want it to be in the Gemini. Just give me a URL to go to. All right, Poe, which is a place I went back in the day. I actually did use Poe a lot. It was one of the first places where they had multiple models. I've kind of long dropped it, but it's cool. It's one subscription and you get to see lots of different things. And from their user base, there's some interesting trends. GPT 4.0, then Claude, then another Claude, and then GPT again, and then Gemini is how people are using their text models. But when it comes to reasoning, people really do like the Gemini models more. You don't even see OpenAI show up till number 4 here, even after DeepSeek. Imagen is killing it. I mean, I do like Imagen 3 a lot. I think that's very powerful. But, GPT Image 1... Image 04, I think, is very superior, but I guess in this system, that one's probably the best one, so I get that. And then with video, I was also surprised. I kind of thought VO2 was going to be the most used. Sometimes I get thrown off by Kling. Sometimes I don't really use it too much, but I know there's always people making stuff with it, but it's really popular. A little bit below Runway, taking up 20% of the people. So a little food for thought there. Now let's look at some research that's called How the Little Prince and AI Help Us Better Understand Language Developments in the Brain. So there's a new study from Meta that looks at how kids' brains develop language skills, and they found some fascinating similarities with how AI models learn. So they used data from people who were listening to the audiobook of The Little Prince while electrodes were monitoring brain activity. And the researchers noticed that even toddlers could recognize basic sounds, but understanding full words or grammar came later and required more mature brain regions. As kids get older, their brains respond more deeply and broadly to language, much like how an AI model improves with more training data. And the cool part is, the way AI like this Wave 2 VEC model or Llama 3.1 learn language from recognizing sounds to full meaning mirrors how our brains evolved through exposure to language. It always has been striking how similar these models are to the human brain, but the continuous thought machines, the patterns in language learning between those larger Llama 3.1 models and how kids' brains put things together. In a nutshell, it means that both humans and artificial systems build language up in a step-by-step way, starting from basic sound recognition to complex meaning in a very similar way. It highlights an overlap in AI learning and human learning, and it's fascinating. Let's get into some opinion articles. Rafi Brianna wrote, "Flying cars won't take off without AI, and this is why. The Jetsons had it all wrong." I don't know when the last time it was you were wondering where your flying cars were, but for me, it was maybe 3 or 4 hours ago. I don't know, dude. My whole life, every time I'm at red lights and stuff, I'm just if I could just go up and over. But I can't, but I still think about it. Flying cars sound amazing, and they have been sci-fi dreams for decades. But real-life versions aren't what people imagined. Instead of the cars you park in your garage and fly yourself, what actually is coming is air taxis. You might have seen these. They usually use the acronym EVOLs, the electric flying vehicles. They're operated by pilots, obviously. They're very dangerous. But ideally in the future, this is a place where AI might literally take off, pun intended. There's some companies that are launching commercial operations. They're focusing mostly on short distances, like airport shuttle service type things. So look, in a nutshell, this is the deal. Like, when AI can drive cars way safer than any human, and you start feeling like, I really hope the other cars in the road have AI driving, because humans are, do weird things and they drink and drive and they get distracted. Then we can take that model, put it into flying cars, and then for the first time, you might have the flying car vision of the future. All right, next up, let's talk about teaching theory of mind to robots and how that can enhance collaboration. Okay, so if you haven't heard of theory of mind, it's a pretty broad concept. You hear it in a lot of psychology books. It's a really interesting topic overall. But it's just the idea that, okay, so you have one entity, creature, person, let's just say human, and they can imagine using like mirror neurons or some mechanism, and that's debatable too, but they can imagine being in the other person's shoes, right? Like we, as humans, we just do this supernaturally, but that is theory of mind. I have a theory in my head about somebody else's mind, and I can imagine that they might want to, I don't know, help me, hurt me, do something, and I can make some predictions about how I want to act, the actions I want to take in the world, because I am making predictions about how the other person wants to act and take actions in the world. So researchers, Duke and Columbia, they've developed this new way to teach robots how to work together more like humans do, and they do include a rudimentary version of theory of mind. And instead of relying on a slow like trial and error or huge data set of like expert behavior, their system, which another good acronym here for you, HUMAC, H-U-M-A-C, which stands for Human-Driven Multi-Agent Coordination, which is the framework that enables a single human to guide a team of robots by strategically stepping in to shape their collaborative behavior, helping them learn how to coordinate with a more human-like intuition. It essentially lets a single human coach briefly to like step into a bunch of robots that are working together and be like, hey guys, like you need to work together differently. And then the robots as a group kind of learn from those signals, and that is a type of reinforcement learning, but it's like kind of a multi-agent, kind of larger framework to sit on top of all these little ones. And it resulted in way better decision-making, teamwork. They tested this with a robot hide and seek game, and the improvement was huge. It went from a 36% to a 48% success rate. So this is essentially what the simulation looks like. And as a god entity over this game, you can see the different agents trying to work together to like do all the hide and seek challenges. And you can talk to either the people hiding or the people seeking and try to give them tips as groups, and then they learn better.
Constantly chases the hider will quickly fail due to the faster speed of the hider agent. We train our seeker to predict a few steps ahead into the future, such that the seeker will implicitly predict the future actions of the hiders to plan ahead. Yet, this is not enough. Collaboration requires the understanding of both the opponents and the teammates. Therefore, we've also developed a novel representation learning method to jointly learn to predict the seeker's own actions as well as its teammate policies. Among all other baseline studies in our simulation, with 20 to 40 minutes of guidance from a single human, our method consistently outperforms all other methods and improves the naive baseline by up to 46% in the challenging 4 versus 4 setting.
Now let's talk about Greg Settel's opinion about why intention will be central to the AI economy. So when OpenAI's CEO Sam Altman was asked about how artificial intelligence will affect the marketing industry, he basically said, essentially nearly instantly and almost no cost, all of it will be handled by AI very soon. So kind of bringing this back full circle to the Netflix thing at the very beginning of the video, this piece kind of dives into why intention is going to be one of the most important things when it comes to AI development. But we don't talk a lot about a society that wants to like craft, like what does citizenship mean? Like what does it mean to be a citizen of the world in the future? What does it mean to be a good father? Like in terms of our relationships with everyone else around us, AI is either going to like bring out the best and it's going to like empower us to be so great at that, or it'll be like so inhumanizing. He argues that human jobs are becoming less about execution and more about defining direction, coordinating efforts, and communicating purpose. Couldn't agree more. Like the decisions from Elon through Twitter and X and Mark Zuckerberg through Facebook and Instagram, and I guess whoever in China is in charge of TikTok, like they will probably be the key deciders of this. Like if they say like, I'm going to put this sort of purpose of the social network in the forefront of what we're doing, and AI sort of comes in and amplifies those messages and curates those in those ways, then we will be in a golden era. Like if they have good intentions, but this is like where we really better hope we have like benevolent dictators kind of on top right now. So yeah, I mean, maybe you could even leave a comment if you're like following along at this point and you've kind of got thoughts about this. Would be something I'm kind of interested in hearing from you about. In the article, he argues that even flashy things like Super Bowl ads need nuanced human strategy to connect all the dots and make an impact. So in the end, however you look at AI, it's a powerful tool on one hand, but it's the humans who are shaping how the agents work, the core functionality, the objective functions that need to bring curiosity, emotion, and the desire to create a better world into the mix. It's like literally human intent that's going to be the big deciding factor on this whole like alignment, super intelligent thing for me. All right, and sort of a side curiosity for me, I'm really interested in complex adaptive systems. Bill Ganakopoulos, probably butchered that last name, wrote this article, Why Some Systems Last and Others Break, a simple guide to persistence theory. And the whole idea is that a lot of different things can be generalized into a network, like say all of the alligators in a swamp or all of the neurons in a brain, all of the trade that happens between companies. And some of these systems don't last for very long, and some kind of eat their own tail. They sort of like become really big and then they like run out of resources, or they strain each other and they fall down. Sometimes countries like go through this revolution where they build these amazing networks, but then in the goal to like keep refining and perfecting and like squeezing every bit of efficiency out, it becomes sort of fragile and breaks. But he argues that systems like memories, machines, or even living organisms that do stick around and don't fade or break down over time do something more than just look at what goes in and what goes out of the system, right? And it kind of comes to this conclusion that for a system to be super persistent, it needs to be reversible. This is the memory glass. Reversibility lets systems hold on to structure. Irreversibility lets it leak away. And reversibility never occurred to me as one of the key pieces to making something really robust. Maybe that's way more important than I thought. In fact, maybe you can even measure how robust and how long-lasting a system might be by focusing on how well the system can reverse its own actions over time. So the more reversible its steps are, the better it holds together. And it's interestingly, maybe the reason the human brain is so good at just keeping us coherent, making us feel conscious and sort of like one entity throughout time is because many of the steps that we use to like create an idea could be reversed. They can go from idea and then break down in a reverse way, maybe. But the standout idea here is that in persistence theory, like whether it's a mind, a machine, an organism, it hinges not on how much energy or information the system has, but on how reversible its actions are. There should be some kind of measure of how like undoable a system is to assess its health in the long run. Anyway, I need to know a lot more about persistence theory, but I know enough now to just be super interested in it. So like, yeah, if you want to like leave a comment or tell me more, or like link to really interesting stuff, like I want to dive deeper into persistence theory. And if you want to help me find more time for endeavors like figuring out persistence theory, head on over patreon.com/Dylan Curious. Still at 91 members. I've been there for like more than a month now. It would be really awesome to figure out if we can get that over 100. All right. Thanks, guys. Hit like, subscribe, join the Patreon.